This
Can someone...
conference will now be recorded.
Okay, good afternoon, good morning, everyone, for this data center facility OCP ready guidelines revision discussion. And see, Gerard has arrived, which is great, as well, as long as everyone else, obviously. So the couple of points and items that I wanted to discuss today were some suggestions for developing the cooling chapter and also the electrical systems. And I think we'll start with the electrical systems and have a look at some information that Rob Bunger has provided to us from Schneider to help us develop reference designs for the existing chapter of the guidelines. So am I able to present now? So I'm going to just okay, thank you. Okay, so I'm just looking now at the suggested changes that we had come through. We had a suggestion from Stein around something I think we need to get a little bit more information. I'm not quite sure on this exactly what Stein meant by this full discrimination. I believe it may be something to do with Art Flash, but maybe that's something for Stein to sort of give us a bit more background.
I'm here, so
yeah.
I can read it. Make it a little bigger.
Okay, yeah. Okay, just sorry. What's the view? 100%.
Maybe too long ago.
No, it was some while ago. I mean, not to worry, Stein. If you want to have a sort of better think about it, either today or maybe come back to this.
Yeah.
And it may come out through other discussions as well. So I just wanted, as you were here, I thought I'd just ask you that question.
Yeah.
But
I'll write it down. Yeah.
Okay, cool. We had a suggestion from Stefan around the having a reference design. It's something also that I thought would be a good idea to develop the guidelines around. So I don't think Stefan is on the call today, but he's involved with their facility in Frankfurt where they're building it to tier 4. And you could also see that there would be a need, some cases where the battery backup in the rack would be used. So maybe a tier 4 type of electrical system would not be maybe not be necessary. So what I've quickly done to add into the into this chapter. So currently, we just have a bit of an introduction and an explanation, some narrative around the type of electrical system we would need. And then we've got a couple of images here and also here with certain parts of the infrastructure removed for a simpler design. But that really doesn't give a lot of detailed information. And Schneider produced a white paper, which is called white paper W228, Analysis of Data Center Architectures. And I've sort of picked out just a couple from that white paper that I think could be useful to explain in a little more detail what that actually means. So, Rob, what are your thoughts on this?
When we a couple of good things about when we did this, God, it feels like forever ago now, is so not only the kind of simplistic part of an electrical design on supporting batteries in the rack, but also just optimizing the the switch gear and the breakers upstream of that, right? So you minimize the amount of wasted capacities on switchboards and switchgear and things like that. And I think we have like this pretty straightforward, and another example where maybe it's PSU in the rack. Since you have mixed loads, maybe PSU in the rack and UPS upstream and things like that. So this can, if we want to I somewhere, and we can dig it up, get the actual drawing of this stuff. Whether I think this might be in Visio. We also have some other stuff in AutoCAD that I'm sure that we can we can submit.
Great, yeah. I mean, I've just done the screen capture from the white paper, just to pop something in there as a sort of just an illustration of what I think would be useful. Just sort of one end, very simple design with battery backup. But I think the this one here, the 2N is probably going to be the most sort of popular and common because of the the transition from traditional IT to IT loads to OCP.
So I asked for backup on this call. I have Gia's on the call right now, and she manages all of the reference designs that we have. And I think has even pulled some of this stuff up too.
And when I was looking through it, there was a link. I mean, you've already provided the link to this.
Yeah.
But I looked in the white paper, and it also referenced that. It also referenced that, but actually the link is broken. From my white paper that I downloaded some while ago. So I mean, it could be that it's been updated since then. But I was wondering whether Schneider would be interested in contributing this. Do you think it would be possible, and do you think it would be of value?
So yes, we can contribute that design. What we'll do is we can go and kind of genericize it a little bit, because we kind of put in products and stuff like that where we have them, but we can kind of remove those names and all the other stuff and contribute that. And when you say Reverend, would you like it? I mean, again, they could be probably PDF of AutoCAD, or also AutoCAD single line diagrams.
Yeah, I think all of the above. I think
both of those. Yeah,
that would be really superb if you're able to.
I think that should not be that should not be a problem. I kind of, when you brought this up a month or two ago, I double checked with the teams that manage this stuff, and there was no concerns about it. So that'd be good.
Yeah. So this could go in the contribution database then.
Yeah, I think so. As a I don't know, whatever. I don't know how you label it. It could be under the white paper reference architecture or what have you.
Yeah. Okay, great. No, that'd be great. No, that would be really great resource, I think. And okay.
Do you think it's worth adding some sort of caveats to these type of schemes? I mean, they're useful for getting sort of non-electrical sort of end users to be thinking about the paths of delivery of power. But as an electrical engineer, I look at that and I don't take this the wrong way, Rob. I would cringe, because having something like 8 or 9 generators onto one bus without any bus couplers breaking up those would be a huge single point of failure in terms of the generator backup, for instance. So I'm just mindful that if we're putting these in a document, are we sort of endorsing this as the way people should be looking at their facilities? I know when we looked at the checklist when we filled it in, there was a very, very heavily underlined sort of caveat that people must do their own due diligence in terms of the sort of security of supply and things like that, for instance. And I'm just conscious that we either need to caveat these and say these are for, guidance only or something like that.
Yeah.
I'm worried that if people read too much into it, and then they have significant fallout because there's a downtime, would they associate that with, well, it says that in the OCP manual?
Yeah, no, that's a good point. Yeah, I fully agree. I mean, especially with generator architectures, there's like 1,001 ways people, will architect generators. Fully agree, and I think we need to. We kind of position these reference designs as, definitely not for design, but more for a starting point for the conversation. But
I think that's great for that kind of thing. But I think if we're going to use them, we need to be careful how we reference them in the so there's distributed redundant, there's cache redundant, there's architecture that supports it. There's so many ways to do it. I think we need to sort of find a point where we give a performance that our customers may be looking for, but the actual implementation is very much down to the individual end user. And if they need to take advice because they don't have that, then that's something. One of the things I've been working on, though I've not actually sent it in yet, Mark, is on the cooling side, responding to Sean Stein's comments about air velocities. So we'll come to that later. But it is. What are we trying to do? Are we trying to give people the tools to ensure that what they're going into meets our sort of general requirements, but they are needed to do their own real checks on it? But the presentation of how they should be looking at it, it is a difficult one, because you're crossing in between a standard and a piece of assistance. So,
I'm just thinking, whether we should simplify the diagram further.
So
it doesn't really look like a design, a design, but something that a more basic circuit diagram.
A couple of things. I mean, one, we can take what we have in the various formats, whether it's Visio or AutoCAD, and have the group look at it, and if revisions want to be made, absolutely, right? No big deal. For submission, that's what the community's for. And the other thing that I've always advocated for, Mark, and I think when we were first doing this, the guidelines is, there's a whole separate industry, and with regards to the actual availability, how resilient do you want your data center? And I always felt strongly that OCP, depends on your application, what you want to do, and so we shouldn't recommend a certain OCP resiliency, just like it's more about optimization and efficiency and things like that. And then how you want to design it for resiliency is there's plenty of other folks in the industry that do that.
I agree, Europe. Yeah, I agree with you, because you get confusion putting these schematics in the guidelines, because then it looks like we are prescribing topologies, and that's not the purpose of the document. So you really get a debate on generator then here, and that you don't want that. You want to avoid that.
Yeah. So I think the level of detail, and I'll gather up the stuff and either get it to you, Mark, or whatever, and I think we can figure out the right way to simplify it, so we avoid that aspect of it.
Because the other thing about the diagram on site there, you've got one site apparently on sort of raw mains, which is fine if you've got the power shelves and battery backup units locally, but then the other side you've got UPSs as a central UPS, if you like. So, which is it we're recommending or not recommending, but should we show a philosophy that doesn't have a central UPS because that's the optimal checklist at the moment, or and some of that will depend on how many actual cabinets out of your data center actually need battery backup. I think there's going to be a knee point in the curve as you go up, where having distributed UPSs on every rack costs more than having a centralized UPS serving a facility. But it really depends on what the app is and what racks. So I mean, I think we need to be able to introduce and describe the arrangements, but then there's got to be a certain value judgment made by the end user or the end user's consultant who's advising them.
Yes, I mean, I think part of what the guidelines are were constructed around what a colo would need to provide, and I think probably at the moment 9 times out of 10 they'll provide a centralized UPS.
Yeah, absolutely.
Yeah, because they're it's not a single tenant. The collation and multi-tenant, and we haven't got to that sort of adoption where every tenant is an OCP user.
So to that point, right? So when so if you deploy an OCP rack that does not have the BBUs in it, then it's like every other rack in the data, from an electrical perspective, almost like every other rack in the data center. So what's the role of OCP? What value are we providing to the community? I think this is a kind of just a question for thought. And maybe again with everybody on this team, we can if we think about the tenets of OCP, of how do you from optimization, efficiency, and openness and stuff, create an electrical infrastructure that's as cost effective, but yeah, I don't know. It's tough.
It is very tough, Rob, and that's why I was hesitant in sort of bringing it up, because I don't want to make, I'm not trying to say that what's provided is not good. It's just that there are different ways of doing it, and it does depend on the customer's resilience requirements. So, I think one of the things that is probably a very sensible solution is that delivery to the rack location should be dual corded. So it's a two-end delivery system, but then upstream of that, it's either UPS backed or not UPS backed. It's distributed redundant or catcher redundant, or 2N, or you know, there's so many choices. How do you capture that, and the specifics of how you do the coordination of breakers, and even to Stein's point about, you know, arc flash, I think we've got to put some onus back on the facility provider to provide that information in openness spirit to a consultant or to an end user that says, right, I'm just concerned about this switchgear, you know, it's delivering 6,300 amps, 400 volts, so the arc flash potential is enormous. How are we protected? But is that something that we, as open compute, should do? I'm not sure it is.
Probably this is it. I mean, it's how much, yeah. To what detail do we go in? We've always tried to think about creating guidelines which are specific to the open rack and or other types of enclosures, and in the future it'll be tanks and other immersion tanks and things like that.
So let me provide some comment here. This is Brevin. So it sounds like we don't want to prescribe a particular architecture. And my question back to the group would be, what other organization, standards organization or otherwise, has the best description of the different types of design and architectures for those generators and power systems? So that's one thing. I don't think that that's up for discussion. We just need to figure out who has that best description that we can then reference. The second thing is what we're trying to do with the guidelines. And the guidelines is supposed to do a description of open compute hardware and how you deploy open compute hardware, what you need to look for. So I think that the first step is, if you are not using BBUs, then you are fine to deploy in a standard configuration. And like Gerard mentioned, you need 2N for failover and needs to be protected by UPS, needs to have generators, normal standard co-location. Then I think that potentially the guidelines have the opportunity to educate a customer on the advantages and disadvantages and what to look out for if they do deploy BBUs, or whether they are trying to decide whether to deploy BBUs or not. And that may be where our biggest value back to the community is saying, now we have a rack that can support in-rack UPS or battery backup. This is the data center architecture that is most effective in that scenario. And these are the advantages and disadvantages.
Yeah, I think that's a good idea. I think that's where we bring value of trying to guide the OCP user down the right route, not to waste so much time on going down a blind alley and choosing the wrong solution and wasting money.
Question for
like a decision. I'm sorry.
Just real quick, a question for Brevin. Actually, I can see potentially more value going to the North American market with our crazy different voltages and stuff. For the OCP racks that you guys have with non-BBUs, are you guys feeding that thing 480-277? Or is it 208 3-phase? And is there opportunity to educate there on how do you feed 480-277 to power shelves?
There is. I agree with you. We just deploy our standard configurations because we are going into sites that were built before 2010, 2015. But you're right. Another section could be, hey, the advantage with OCP, because you have control over the power supplies that you put in the racks, they can be designed to support up to that 277, and that could be another educational opportunity.
Yeah. Okay.
Okay.
Mark, regarding my point, I looked it up in my notes. Sorry, Stein here. I looked at it in my notes, so I got the reasoning behind. I put it in the remarks in the chat section. That it's all about those studies, arc flash, coordination, short circuits, are getting more and more important that a data center is assessed as OCP ready, that those studies should be made. So it's clear what rack and what rating the racks can handle or expect in a short circuit situation, because it's getting more important. The racks will use the power. In the old times, it was not so important, maybe because the rack power was not used, but this, yeah, a proper data center now times, and also maybe the UPS in the rack. It should be totally clear what the interconnection can expect from both sides.
Do we have any information on in-rack BBU and technology in terms of peak shaving and load curtailment, or whatever that term is? Peak shaving. Go with that.
I don't know.
We know of anybody doing that?
A lot of talk, not that I know of yet.
But I don't know if in the rack version 3 design conditions there is I don't know if there are some paragraphs on the electrical ratings and stuff like that. So that the electrical system can know what the rack level version 3 can expect on for the electrical design. What's the impact of an OCP rack, of the maximum impact?
Oh, and here's another question. Has anyone gone past a 60 amp 208 or a 32 amp 3-phase 230?
We're about to, yeah.
Oh yeah,
There it is.
there we go.
But actually, I mean, you do raise a great point, because obviously I've been sitting on the Don Mitchell ACS calls, and people are starting to talk about 125 kilowatt cabs. Well, the largest IEC 309 connector you get is 125 amps, which is going to equate to something like 82 kilowatts. So what do you start doing for 125 kilowatt cabs? I mean, it almost becomes, you either have multiple 125 amp connectors, which are or they become fixed installations. If they become fixed installations, there's a whole bag of other tests and certifications that will be required. So I mean, there's an awful lot to consider, and the rate the market is moving. I don't know how quickly we can respond to it, because I know I'm challenged myself in terms of some of the time I can commit, but they are certainly things to consider. But we're looking at putting 63 amp connectors on bus bar above cabinets at the moment for a liquid cooling application.
So like three phase 63 amp.
Correct.
Yeah.
So that's 44 kilowatts a pop.
Yeah.
But then when you've only got a 250 amp bar above, it doesn't take many of those before you've used up the whole bar's worth.
I know, crazy.
Section. So it's
interesting, the short circuit calculation on that one.
Yep, absolutely. This is the problem I see, is how we put enough information to make it useful for someone to help select a site, but then don't go too far down that we start almost inciting sort of design responsibility.
Yeah.
Liability if something goes wrong. It's a case of we've got to push some of the safety stuff back.
Yep.
From Stein's point of view, for instance, there should be on the checklist, arc flash studies done. But I don't think we want to go into too much detail about what they should be protecting. Someone's going to make their own assessment of what equipment they get access to, and
Exactly. Yeah.
yeah,
Yeah, and there's plenty of value in just having it on the checklist, just so that people know to ask the question and understand what it is. Yep.
yeah, no, without doubt, Rob. Because some people, you know, unless they go and employ a consultant to start with, wouldn't even know to ask those sort of questions.
Yeah.
So we're saying then we should be changing the colo ready site assessment to add further to the electrical section.
So I guess I'm wondering, because what we're trying to build here is almost a sort of description of what the data center should be, aren't we? What might be sort of safer is actually putting more requirements in the checklist for people to go off and do their own bit. I'm just concerned that the pace that the market changes, and clearly even just us trying to change the checklist, you know, it takes quite a large amount of time to do. Is how we keep pace with that change if we're going to go into lots and lots of detail. That's just trying to be practical.
Yeah, I agree, because you see a lot of changing in the resilience reasoning. Maybe one feed and a maintenance bus bar I saw also. So that's we cannot keep up speed there. And with that speed, that should be developed per data center and assessed by the user. But yeah, just putting on a checklist that the proper calculations are done, then yeah, that's only a check mark if it's done. It's not about the outcome or the value, but just are the calculations made. That's it, and then they can supply those reports, and then they can assess at that time if the equipment moving in is applicable for those calculations, or new calculations should be made because the equipment is too heavy. Yeah, that's the. I think that kind of level we are looking for in this checklist. Otherwise, we are then we move to a design area, and yeah, that's difficult in this document.
Okay. So we just okay then. So it's going to be a consideration then.
Yeah, apologies if I'm completely messing up the whole process, but I'm just.
No. This is
good.
This is
good.
This is a great discussion and very important to really think through what we should be doing as a group, and really as Brevin said, and I think this is for other things as well, where we should be referencing other organisations that have already done this, you know, like ASHRAE or Green Grid, that we don't reinvent the wheel. We, you know, as people involved in the industry, we know, you know, it's getting that feedback from everyone. Well, who else is doing this? Who can we reference? And we just put a reference in there. If you want to know more, go here.
Yeah, and I think that sort of came out really of Dom's call yesterday, is that actually the liquid cooling market or advanced cooling market is still relatively embryonic, and people have got proprietary way of doing things. If we try and fix it to one of those guides, you're almost restricting innovation, or forcing people to design to something that may not suit everybody. So it's really the outputs from the cooling scheme that we want to encourage people to explore, not what lies behind the curtain, I suppose, is where I'm trying to get to.
Yeah.
Appreciate the insights there. Thanks.
I don't, sorry.
Okay, is there anyone that would be willing to create some narrative around advantages and disadvantages of deploying battery backups in racks, you know, utilization of centralized UPS, upstream rather than rack level, or is there anything that's already been written out there that we could
Yeah.
plagiarize?
Yeah.
Um,
So I mean,
Mark, this is, oh, sorry. Go
no,
ahead, Rob. But
please go
I
ahead.
just want to mention quickly, there are some companies that already have solutions with batteries in rack, and in fact, they have power supply units that have um, up to 4U of space that is filled up with batteries. The challenge is always the safety, the safety that's associated with battery performance and all that, and what happens if fire occurs in the area and it gets to the batteries. But there are companies that I know of who already have solutions, and I would like to volunteer to help with information related to features, benefits, and whatever needs. But I don't want to engage in this alone. I would like to see that at least one or two other people want to cooperate and contribute to come up with information for that sort of
Yeah.
stuff.
Yeah, and to to add on that, I think again, it might be a bit dated, but the white paper that you referenced was our kind of our cost analysis of what that looks like, I believe.
Yeah.
And with regards to removing the centralized UPS, putting batteries in the rack, and it is good. It all depends on how much stranded capacity that you end up having. If there's homogeny in the rack loads, you're in really good shape. If it's going to be highly variable, then you could overshoot and then spend too much on the stuff in the batteries in the rack. But that's a publicly available white paper. This could be a starting point.
Okay. So I mean, I'll share the link to the white paper, or I mean, I can after the call, yeah, just really needs some volunteers. I mean, so Gabby, thank you for your for putting your hand up. Is there anyone else that could assist Gabby with this?
Mark, I'd probably be happy doing a reviewer role to sort of sense check it, but I've not had experience of using BBUs, and I am concerned about overcommitting, but I'm certainly happy to review and provide comment on that, as opposed to some of the other stuff where I'm trying to help contribute. So you could put my name down as a reviewer, but as I say, just concerned I don't want to overcommit.
Sure, no, totally understand.
Now, are you?
I'm sorry. You know what I'm thinking, Mark? Maybe we can. I know of a company that recently joined OCP, and I'm going to try to get in touch and figure out if they want to become part of this group and see if they want to, take more of a contributor role on this section of, UPS with battery backup, peak shaving, all these notions that are sort of ambiguous now. And there's another thing that I see evolving a lot is that virtually defined power, in other words, like really monitoring the power demand before anticipating power demand, and basically be able to supply the power or have the power there before it's actually needed. It's like a backwards concept that is taking shape. So I'm gonna try to figure if I can bring somebody in the group who can contribute more.
Okay, great, thank you.
Well, Mark, are you envisioning the work in this area to be part of the facility guidelines, or just a separate contribution for the data center facility group?
Well, it's been really, so we're just focusing on the guidelines. But if there's requirement or need to do more work on the electrical area, then maybe that could become obviously up to Rob and Brevin and Anand about whether we want to produce a sub-project around the electrical side, because I know there are other aspects that that have been highlighted by Facebook around, you know, stability, electrical stability, impedance matching, and other.
Yeah,
That's
and that's an interesting topic, because was that an issue with the profile of the early PSUs, or what was the deal with that?
No, it's a huge homogeneous environment. So if you have all of the same at that level, they were getting the same harmonics on every single PSU. And so it was just adding up, and it was very interesting. It's worth a review. Obviously, I don't know all about it, but they were pretty detailed in their videos and presentations that they've done.
Yeah, so the each individual PSU looks kind of good, right? Sort of close to power factor 1, blah blah blah. But you grunch a bunch of them together on the same circuit, and it all adds up.
Yeah.
Yeah.
Yeah. So so there are some other aspects that certainly, you know, users need to be aware. I mean, with Facebook, they'd only been testing it for 1 megawatt loads, because that's the minimum that they deploy. Whether it's you know, it's valid at lower loads, I'm not sure. But I don't. The white paper, I'm not sure whether they've actually created the white paper yet. Yeah.
They have not, and I did follow up on that. They were not planning to or expecting to, because they had been distracted by other competing priorities.
Okay.
So we'll keep up on that, and see if we can get that contributed at some point in the near future.
Yeah. Okay. So yeah, so it's really you know, it's the guidelines, and okay, let's right, we've only got about 13 minutes left. So the other thing I wanted to just discuss was around the IT space. Now I've been provided with sorry, I'm just going to bring up a document that has been sent to me by so this is, and I'll share a link to this after the call as well. So this has been contributed by Rittal and MainCubes. This is the installation that was carried out at AMS 01 in the Netherlands, and I thought it would be a good idea to maybe have some reference designs for a pod, for a white space, for installation in a white space. So this is effectively, it started out with 3 V2 racks in a row, and also, you know, with blanking panels within the pod as well, and the ability to extend the pod further in the future. So as sort of a description and of phase 1 and then phase 2, where they're looking to increase the racks beyond the current size. There's some information about the delivery and that, but there are some drawings here, quite basic drawings. I'm getting in touch with Rittal to see if we can provide, to see if they can provide some further drawings and whether there's any more detail to this. But this sort of shows the sort of frame of the pod and some elevations, and we've got some photos as well. But with the so you can see from this, the actual pathways are external from the pod itself. Doesn't look like the actual pathways run over the pod. So there's some more elevations. So I just be interested to get anyone's thoughts on providing this type of detail, providing sort of example pods designs for the guidelines. What does anyone think?
It looks like you have several examples from different sources, which can allow us to sort of combine, consolidate, and convey as best practices, not just a single source. And this is how you do it. So there's a few different ways to do it. Yeah, I'd say let's put a section associated with pods.
Yep.
And get approval to add all these pieces in there.
Yeah, I concur. I've always liked the pod methodology and freestanding, infrastructure around it. It's good.
And Rob, you've offered to maybe to provide some information around the hyperpod as well, which is a sort of along the similar sort of modular lines of construction, but maybe it's got a little bit more inbuilt into the actual design that you have, which is, I've seen it before where you've got these sort of electrical switchgear or distribution panels built into the
or hanging bus bar above it, however, a lot of different options. Yeah, so it's very similar to this. Yeah.
I mean, have you got any photos around real world sort of deployments of the hyperpod?
Yeah. Oh yeah, I'm sure we. Yeah. So let me. I get writing some freaking to-dos down here. Yep. All right.
Welcome back, Mr. Bunger.
I seem to be leaning on you a lot today, Rob. But
damn it! I blame this on you, Mark. Is all I gotta say. I was able to hide for a while.
You're far too useful to hide.
I appreciate we are coming. We are fast approaching the bottom of the half hour. Who is the best person to talk to in terms of Delta T that designing for across OCP servers?
Airwise, right?
Yeah.
I've wondered that too.
I was actually just thinking about that. You're talking about the massive amount of airflow, and I was looking at Stein's comment. This could be a place to provide a scale or guidelines around that, where the OCP user can have a conversation with their OCP cabinet designers, as well as their colo facility provider or data center provider or designers, and make sure that those meet up, because we are expecting that it's at least 12 degrees delta T in terms of their set points, but obviously it can run up to 20 degrees and still be functional. And I know that there are quite a few pieces of kit out there these days that have that 20-degree delta T across their chassis. So coordinating, obviously, delta T to airflow to power usage, we should have some kind of, we should be able to get some kind of a chart, table, guideline to inform and educate an end user.
Yeah, because obviously some of the work I've been doing, which, as I say, I haven't submitted yet, but was in response to Stein and Sean's comments, were really about the airflow that you're going to get down a corridor. You know, traditionally we set them at 1.2 meters wide, but that's fine when you're sort of 5 kilowatts, maybe a bit more. But once you go over 2.5 meters per second airflow, certainly right at the start of the row, you're going to start, if you're not careful, what we used to see coming out of raised floors when the velocity is so great it shoots past the first 5U and misses those servers, and they start to overheat and recirculate. So, you know, there's probably a guideline of 2.5 meters per second ideal airflow, maximum of say 4 at the sorry, someone's calling me and I can't cancel it.
We can still hear you though.
Shows my ineptability at IT, doesn't it? So if we, you know, I can put it in terms of that, but then if you're going to go up in density, you know, that dimension of the row needs to grow in say 600 mil steps or 2 feet steps, depending on what it is, up to a certain amount. And there's got to be some sort of guidance given probably for an optimal layout. But again, there's going to be a whole bunch of work that an end user would have to do in terms of, well, what does my app use on a per rack basis? You know, is it 20 kilowatts in every cab, or is it some at 3, some at 7, some at 25?
If you look at like the total power consumption and then hopefully thus airflow of like a pod, is that good enough to understand then like what your aisle width might need to be?
I think it certainly is enough to give guidance, and that's what I've been working around.
Yeah.
But I think we'll probably have to have some caveat that, you know, individual studies may have to be run, or if a colo provider has got a model in CFD already prepared, you know, they should consider perhaps spending X amount to simulate what their particular layout will be. You know, I mean, we see it as a design. You know, we design for an average. Our first round is average of 5 kilowatts a cab, but nobody takes 5 kilowatts a cab. Some are 2, some are 10, some are 20. You know, it's all over the shop. And it ultimately, as we probably get over 2/3 full, we'll probably start seeing some hotspots, and we'll have to engineer around those. But
yeah, that's really good. I like.
Okay, so
I think that. Yeah.
sorry, Karen Stein.
Oh yeah, it's I said I agree with how said. So also there a model with proof of concept that a certain setting is working, and then for the individual case, the model can be recalculated to see if it still works. Such things, but not going too deep in detail, but also as a reminder that aisle length and aisle width and rack densities are connected to each other, and it's not that you can stretch every dimension freely.
okay, so well, I'll try and word something around how you look for those things and give people the clues to work it out, but maybe not give every permutation. But at least that's good. I've got some guidance. I can give you a draft on that.
Yeah. Are you thinking that could be like a couple of lines in the checklist of like considerations and like extremes and things like that?
I think, yeah, probably have to. I mean, maybe in the actual guidance we can sort of set out a little bit more how you approach it. Then in the actual checklist, Yeah.
Yeah, cool.
Directive. So yeah, okay, cool. I think I'm good. Sorry, I've been trying to steal the limelight, but I'm trying to manage to do something by next meeting.
Okay, that would be great if you could provide something around that design considerations. Yeah, so should we have another meeting in a month's time, or do you feel we should have another one in a couple of weeks' time, or depending on obviously with other other meetings that we have already scheduled?
My own view would be, I think it needs to be 2 weeks, otherwise it's going to stretch out too long. People will have to try and manage as best they can, but I think if we leave it a month, it's just going to take too long to pull together. That would be my view.
Yes, and I think what we're sort of leading up to the Tech Week as well, and we do have we've got a slot within the Tech Week of about 40 minutes of discussion, and I think one of the things that would be good for everyone to sort of consider is what are the problems, what are the things that are really important to a user that we should be providing guidance around. And I think we're already highlighting this around the electrical side of things, around the considerations and also the cooling. So I think the and something that Brevin has mentioned, we're trying to sort of maybe try and focus on things that are really key points to help users with adoption. What are the problems that we need to fix or to help people fix, and it could be this high power requirement, for instance, that you mentioned, Gerard, that's coming down the track.
And maybe as we tried a couple, like how are PSUs getting deployed to fulfill these high power requirements, right? Is it, are you going to need 4 32 amp 3-phase feeds, because there's 2 different PSUs at 2N, or how, understanding that might be good, and then we can make recommendations on the power feeds to it.
Okay.
Yeah.
Okay. That's certainly something we should definitely consider having further discussions around. Okay, that's great. Well, thank you very much, everyone, for coming along to this this call, and thanks for your contributions and help. And I will schedule something in the next sort of two or so weeks, certainly before a month's up, and we'll have a further discussion and make some progress. So anyway, thanks everyone.
Thanks, Mark.
And have a good
Mark.
rest of the day. Cheers. Thank you.
Thanks.
Cheers.
Goodbye, everybody.
Bye.
Thanks,
Bye.
Mark.
Bye.
Bye.